This video is going to introduce the concept of factoring, specifically focusing on the idea of the greatest common factor, which we frequently abbreviate with GCF. The greatest common factor is the largest number that all terms, or all numbers you're dealing with, are divisible by. So for example, if I have the numbers 15 and 27, the GCF is the largest thing that I can divide both 15 and 27 by. In some cases, you might be able to just think about your times table and various factors of 15 and 27 and come up with the number. But if you can't, there's a really nice strategy you can use to find greatest common factors. You can create a factoring tree for each number. For example, 15 is 3 times 5, and we cannot break down the 3 and the 5 anymore. Those are prime numbers. 27 is 9 times 3, and we can factor that 9 as 3 times 3. So 27 would be 3 times 3 times 3. Then you look at the prime factors for each number, and you see what do they have in common. In this case, they only have the number 3 in common. So my greatest common factor, or GCF, would be 3. 15 and 27 are both divisible by 3. Now again, if you can do this in your head, you definitely don't have to write out the factoring trees, but it's nice to have a method when you're feeling stuck. Here's another one. We've got 30, 18, 24. What is the largest number that all three of these numbers are divisible by? Let's use that factoring tree method again. 30 is 3 times 10. 10 is 2 times 5. So the factors of 30 are 3, 2, and 5. 18 is 3 times 6. 6 is 3 times 2. So 18, 3, 3, 2. 24 is 6 times 4. 6 is 3 times 2. 4 is 2 times 2. Then I compare the ends of these factoring trees to see what they have in common. All three of these numbers have a factor of 3, and all three of these numbers have a factor of 2. That's the only thing they have in common, so my greatest common factor would be 3 times 2, or 6. And so all three of these numbers are divisible by 6, and that's the largest common factor that the three numbers have. What if we introduce variables into the problem? Turns out we can use the same type of strategy. For my first term, 10x cubed y, I know 10 is 2 times 5, and I can write x cubed as x times x times x, and then let's see, we also have a y there. I can factor the second term, 15x squared y squared. 15 is 3 times 5, and then we have x times y times y. We can use the same process of looking for factors or things that these terms or these numbers have in common. They both have 5s. They also both have 2 factors of x and 1 factor of y. So the GCF would be 5x squared y. Now, if you don't want to write things out and you're trying to find a greatest common factor and you have variables, another way you can do this, for the variable part of your GCF, check and see if the variable, the letter, is in both terms. So for example, x is in both terms, and choose the one with the smaller exponent. So we have an x to the third and an x squared, so I choose x squared. I notice y is present in both terms. We have a y to the 1 and a y squared. I choose the one with the smaller exponent. So y is part of my GCF. Let's do another one. I've got 11ab, 5a squared, and 3b. 11 is a prime number. We can't factor that. 5 is a prime number. I can't break that one down. And 3 is a prime number. So 11, 5, and 3 do not have a common factor. Then if I look at the a's, I have an a in the first term, an a squared in the second term, but notice the third term does not have an a. There's not an a in all the terms. That's not going to be in my greatest common factor. Okay, what about the b? There's a b in the first term, and there's a b in the third term, but there isn't one in that middle term. The b is also not present in all three terms. So these three terms, we could say they don't really have a common factor. When that happens, you could say your greatest common factor is 1, because everything is divisible by 1. 1, I guess, is the largest thing we can divide these three terms by. Now, why are we talking about greatest common factors? Because that's our first step to this factoring process. And factoring, as a verb, means write as a product. So we're undoing our multiplication and trying to write an expression as a product, as multiplication. So I've got the expression, or the polynomial, 3x squared plus 6x. I'm going to find my GCF and put this in factored form. So my two terms are 3x squared and 6x. What is the largest thing that I can divide both of these terms by? 3 and 6 are both divisible by 3. Both terms have x's. I choose the one with the smaller exponent, so the GCF is 3x. To put this in factored form, I'm basically going to pull the 3x out front, so it's like I'm undoing that distributive property. And then to write down what's left over, to figure out what's left over, I'm going to divide both terms by 3x. So if I divide the first term by 3x, the 3's cancel out. X squared divided by x is x. If I take 6x and I divide it by 3x, x's cancel out. 6 divided by 3 is 2. And so I'm left with 3x, parenthesis, x plus 2. That is my expression in factored form, or written as a product. Now the nice thing about factoring is you can always check your work, and the way to check your work is with multiplication. If I distribute the 3x to the x plus 2, I should get what I started with, and that's a really nice way of checking your work. 3x times x is 3x squared, 3x times 2 is 6x. Here's another one. Find the GCF and write in factored form. So what is the largest thing I can divide both 8 and 32 by? The answer is 8. 32 is divisible by 8, so we'll be able to pull out an 8. And then I notice that both terms have an a and both terms have a b. So my GCF is 8ab. So I'm going to pull the 8ab out and see what I have left over. To figure out what's left, we divide that GCF out. First term, 8's go away. We take out an AB. I'm left with an AB. Second term, AB's cancel out. 32 divided by 8 is 4. And there's my final answer, 8AB, parentheses, AB minus 4. Again, if we wanted to check our work, we could distribute and make sure we get what we started with. Next example, find the GCF and write in factored form. I've got 36y squared minus 24xy plus 16y. So what number is 36, 24, and 16 divisible by? If it helps, you can make those factoring trees that we discussed at the beginning of this video. But when I do these problems, I first try to think about just my times table. Like I notice, let's see, 36 and 24 are both divisible by 6. Oh, but 16 is not divisible by 6, so that doesn't work. What about 4? Oh yeah, I can divide 36 by 4, 24 by 4, and 16 by 4. So that's going to be in my GCF. And then I also notice that all three terms have y's in them. There is an x in the middle term, but not in the other terms, so there's no x in my GCF. So my GCF would be 4y. If I pull the 4y out front, I'm dividing it out of the terms, and what I'm left with would be, let's see, 36y squared divided by 4y gives us 9y. 24xy divided by 4y gives us 6. Y's cancel out, left with an x. And 16y divided by 4y is 4. Scanning this answer, I can see that I did actually get that greatest common factor because there's no other common factors left. The numbers now are 9, 6, and 4. They don't share a common factor, and there's no variable that's left in all three terms. We can also distribute, make sure we get what we started with to check our work. Here's one more example that looks a little bit different, but we can actually factor using the same type of strategy. We've got 2x, parenthesis x plus 1, plus y, parenthesis x plus 1. So technically, this problem, we can treat it as something with two terms. The 2x parenthesis x plus 1 is a product of things, so we can think of that as one term. And then the y parenthesis x plus 1 is also a product, and we can treat it like it's just one term. And so looking at those two terms separated by the plus sign, what do they actually have in common? The only thing they have in common is that x plus 1. And so we can treat that like our greatest common factor. These two terms both have an x plus 1 in them. So I can pull that x plus 1 out front. And then if I divide by x plus 1, I'm just left with the 2x, x plus 1 went away, plus y. And there's my answer in factored form. We're going to stop there and continue talking about factoring in the next video. In the meantime, as always, please let me know if anything is unclear.